Well, I'll just take the attendance while you're finishing that. So HS1, Mahmoud, Gafar, what? Amjad?
Well, I didn't say anything. Why is it always it says Mahmoud is not here.
Right, let's start again. Mahmoud?
Here.
Yes, thank you. Gafar? Yep. Amjad? Yeah, no, definitely know that. Zara? Yep. Mo?
Yeah.
Daniel? Yep, correct. Sevi? Sabrina? Alfreda? Yep. Arya? Chiadi? Young Pang? Amna? Mariam? Oh, there. Michelle? Abir? Yeah. Autumn? Yeah. Celine? Okay. Sophia? Yeah. Mubarak? I thought so. Chadira? There. Mohammed? Yeah. Sabrina is not. Okay. Moza? Angela, Ahmad, Sahra. Yeah. Okay, so Mubarak and Sabrina. Sabrina's sick, but what about Mubarak? Do we know? He wasn't in at all today. No. Yeah. That is a very good one, and we won't see that until semester 2. Logs will need to be used for it. Yeah, we won't actually be able to do that until we do a topic called Implicit Differentiation. This comes around about the chapter when we're doing product quotient and chain rule. That's not until semester 2. Yeah, so XX is a little bit advanced. We're only going to deal with X with a number, for semester 1. Okay, we'll continue now. If you can look up, please. Guys, look up, please. We're continuing. Sabrina? Okay. So in the previous lesson we saw the first principal rule for calculating the derivative, which we said is the slope of the tangent. But of course, as Amjad pointed out, this is quite a long process, containing not 1, 2, 3, 4, but 5 lines of maths. And we would like to cut this out and reduce it to 1 line. So what we're going to do is try to find a quick rule for getting the derivative of functions such as functions of the form x power n. Now some of you know what the result will be already, but let's try and figure out what the derivative of such a function will look like. I am not specifying the power, I'm leaving the power as n, so we can choose whatever power we would like, and we can arrive at a rule. So let's see what we get here. We'll have to calculate this first. So that will look like x plus h power n minus xn over h. So I'll just start first by calculating the secant slope, and then I'll put the h0 at the very end after I simplify it fully. It'll take a bit of work to simplify. Okay, so we have this line written down. Yeah, okay, so we need to expand this. What would be the easiest way to expand this? We have 2 methods for expanding. That is not one of the 2 methods. How can we expand here? We have 2 methods. What are they? Binomial and Pascal. Which is better here? Binomial. Okay. So binomial. I need your full attention, or get out. Thank you. Right. So we applies to everybody. So we use binomial expansion. We'll have NC0 X and H0, which is none of them. Then the next one is NC1 X N minus 1 H, yeah, H1, yeah, plus NC2 X N minus 2 H squared. And this continues, right? Minus Xn all over H. Now, I'll just pause for a minute to let you write this line down. Okay. Because the next bit now we need to simplify this a little bit. Now, we know what NC0 is. What is it? 1. And you might recall what NC1 is. Not 1. What is it? N. Yeah. Because we remember that the second number after the 1 on Pascal's triangle's row is always the row number. You know, like it goes 1, 2, and then the next one goes 1, 3, blah, 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 and then 1, 4, blah, blah, blah. So we know 2 of these. We know this one, and we know this one. And for those of you who remembered the tutorial we did a few weeks ago, you realize we have a formula for NC2. It was something like a half n plus 1, but we'll rework it out again on the side here, okay? So I'll just go to the side for a moment. You have this? Yeah. So we'll need to write this down if you recall. NC2 is n factorial over 2 factorial n minus 2 factorial, which is n minus 1, n minus 2, n minus 3, etc. over 2, 1, and then n minus 2, n minus 3, etc. Do you remember this? We did this a few weeks ago. So cancel, 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 and you're left with n minus 1 over 2. Okay. And you can actually test that out. You know, if I calculate 10C2, apparently that's supposed to be 10 times 9 over 2, which is 45. So if you check it, you should get 45. Okay, so if you can write this side note down, we'll go back to the main proof in a moment.
So NC3 would be n minus 2 over 3.
Oh, if you want to try and figure out NC3, yeah, it would be, this would be a 3 factorial, so there'd be a 6. And then what would happen here is n minus 3, so you'd have an extra n minus 2 on the top. So it'd be n minus 1, n minus 2 over 6. Yeah, so you can kind of figure out a general pattern here. n minus 1, n minus 2, n minus 3 over 24. Yeah. Anyways, we don't need to go that far. This is enough. Can we go back to the main proof? Yeah. So let's sub in our values we know. We know that NC0 is 1, so that becomes Xn. We know NC1, that is n. We know that NC2 is n minus 1 over 2, Xn minus 2 h squared, dot 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 minus Xn all over h. Now this is looking very complicated, but the great news is a lot of things will start to cancel now. So I can cancel that Xn with that Xn. Now this has a h in it, doesn't it? So I can cancel it with h. This has a h in, doesn't it? Yeah. In fact, what will the next one have? H cubed. And the next one? H4, and so on. So the first part becomes n x n minus 1, h over h, gone. The next one will become n minus 1 over 2, xn minus 2, and h squared over h, h. And the next guy, we don't know what it is, but what will it have? It will have a h squared, and the next one will have a h cubed. Now, even though I don't know it, that's fine, because now we'll make the h go to 0. So what happens to all these pieces? They're 0. So you're left with the derivative of xn is nxn minus 1. A result that some of you are familiar with. So you can say that the derivative of x power n is nxn minus 1. That's the result.
What time is this up?
11:45. Did you write this down, Amjad?
Did they ask us to prove?
No. So let's test this out. So what I'm saying is, if you have something like x6, its derivative is 6x5. Okay? Let's test it out with an example that we had. Let's use the same one we did at the start, where the answer was -3. Let's apply the rule to that one.
9x squared.
Yeah, can we write it down?
9x squared.
One sec. Do you have this? What was it? 9x squared
Minus 3x.
minus 3x
Plus 4.
plus 4. That was the y, was it? Can I scroll down to it? Yes. I'm not seeing anyone say no. Okay, so before I begin, let's clean this up a little bit. This is 9x squared. This is 3x1. And this is 4x0. According to my rule, the derivative should be this. It should be 18x1 minus, now if I bring the 1 down, 3 times 1, 3, and what power do I have now? 0. And if I bring the 0 down, 0, x power, no, minus 1. The power comes down and you take 1 from the power. That's the rule.
So you can divide by x.
Take the power down and take 1 from the power. Now, which can we cancel here?
X.
Well, obviously this. And in the question I gave you, what did I say the value of x was?
0.
In this one was 0. Okay, so 18 times 0? Oh, what's x power 0 actually? 1, so I can get rid of that. So that's all gone. So I'm left with 18 times 0 minus 3, which is minus 3. So you've now seen 3 ways to get this slope. By using the discriminant, by using first principles, and by using the rule we've just found. 3 ways. So what I'm going to show you now is a table of derivative rules. So we've just seen one rule there, the x power n. But there's rules for derivative of sine, derivative of cos. And you can prove these rules by using the first principles formula, which is not necessary for us to do. So I'll just give you the results. Can I scroll down to the table? Not yet? Okay. Some of you know some of these rules already, like what is the derivative of sine x? Cos x, yeah. Cos x? Sine x. Ex? Yeah. Okay, let's scroll down. So, right. The first rule, so I'm giving you a table here. On the left is the function, and on the right is its derivative. Okay, so we just proved that the derivative of xn is nx n minus 1. That's our first rule. Our second one, it's similar to the first one, and you've actually seen an example in the last lesson. If you just have a constant by itself, what's its derivative? 0. Like in the example of the number 5 in the last lesson. And if you have something like a constant times x, its derivative is x. Now, you already know this, okay? If you have a line, say the line 5x plus 3, what's the slope of 5x plus 3? 5. So this is not a surprise, because the slope of mx plus c is m. Okay, so it's not a shock that the slope of kx is just k. The derivative of kx is just k. Right, now, on to some new rules, where we don't need the proof. So the derivative of sine x is cos x. Derivative of cos x is minus sine x. Derivative of enx and enx. 7. Oh, sorry, I skipped tan, didn't I? Tan x is. Does anyone know tan x?
6.
Yeah.
6 squared?
Yeah. 1 over cos x. 1 over cos squared x. Yeah. Secant squared. Yeah. 8. I haven't done log yet. So log x. Does anyone know log x is? 1 over x, yeah. Yeah?
1 over x minus 1, then x.
No, 1 over x for log x. Not yet.
1 over x.
What's that, yeah? Number 7? Oh, tan x. That's something else we'll do later. Have you got these rules? I'll just scoot them to the left here.
What time is it?
That one is at 18. Now, you have these in the formula book, but they're not exactly like this. For example, no, tan x is in the book. I don't think these two are. And I believe the rest are, though. They're in the formula book. I think so. It's on Moodle. Now, this is actually nice because it means some difficult problems you can actually do using this formula book. So if I said to you, consider the function, here's an example, y equals 1 over root x. What's the slope of the tangent here? What's the derivative of this? You can use your rules. In fact, which rule would you need here? First one. Okay? Oh, goodness, sorry. 1 over square root x. Okay? The problem is we have to rewrite this a little bit at the beginning. Yeah? So before I calculate the derivative, that is, before I find the slope of the tangent, I should write this as a power. What power is that? Minus a half. Because it's both the reciprocal and the square root. Right, let's apply the first formula. So the slope is bring down the power and take 1 from the power. Reduce the power by 1. So what's the new power?
3 over 1.
Minus 3 over 2. Now, I can write that back as minus 1 over 2 square root x cubed. Yes. Yes. But they don't usually require that in the exam. Usually in the exam they're quite happy if you stop here. And in the exam they sometimes provide a value, so they might say at, let's say, x equals 2, So in this one here, if I put in x equals 2, what do I get? No, 2 is an ugly number. Let's choose a different number. 4.
Shouldn't it be minus 1 over 2 over?
Hang on, let me check that for you now in a second. Gafar. I'm just changing it to 4. Okay, sorry, go ahead. What's your question?
Shouldn't it be minus 1 over 2 over 2?
I think this is right because the square root is because I have a half in the power. The cubed is because I have the 3. You're giving me the next part. I think this is okay. I think so. Right, so if you put in 4, what did you get? Minus 1 over 16 in total? Yeah. Now there is a way we can check the answer. I'll just open the calculator here. You can obviously do this on that calculator, right? That looks like it, yeah. Right. Look up, please. Look up. So, we can check the answer on the calculator because we have this function on the calculator. Where the heck is it? Shift derivative. The x here is 4, and I want the derivative, the slope of the tangent of 1 over root x. Wasn't that the original question? So I should get minus 1 over 16. Now, it gives it to me as a decimal, but I'm sure that's it. I can't convert it back. So, this is good. In the exam, you can check if you got the right answer. It's very convenient. Yeah. Now, let me give you one to try. Can I scroll down? You all have this? Okay, I want you to try this one for me. I'm not going to give you a value for x, just leave x in your answer, okay? So give me the derivative here.
This is log, yeah?
Log 3x, yeah.
What is the slope of the motion?
3x minus 1, the power minus
It is not. 1 over x. 1 over x. 1 over 3x.
and so 3x
Be
Which? Yeah, the answer is 1 over x. Yeah.
Where does the 3
Now, I'll show you, okay, because this is a question that half the class is likely to get wrong because they get confused with the 3, okay. When I gave you the formula, Jed, if I am interrupted by you again, I'll ask you to leave. I've reached my maximum limit for you, okay? Like, you know, I've reached the limit. I didn't think it was possible, but I've reached the limit, and any more, you're out. No, I can. I've just reached the limit, okay? So, if you look at the formulas I gave you very specifically the derivative of log x, didn't I? I didn't say the derivative of log 3x or log nx, I said log x. Do we have log x here? Well, not quite log x, exactly. It's log 3x. So, we cannot use our formulas. We first have to simplify. But we can simplify using the rules of logs. we can change this into log x plus log 3. Which rule of logs is that? The first rule. Yeah? Now, what is the derivative of log x? 1 over x. And what's the derivative of log 3? 0. Why? Because it's a constant. And we said derivatives of constants are 0. So the answer is 1 over x. Yeah? Now you see, just because you have rules doesn't mean you'll get the right answer, because you have to correctly apply the rules. Like in this example. It wasn't too difficult, but you all made the mistake of thinking, oh, well, not all of you, but because I have log x, I can do this one. Well, I didn't give you log x, I gave you log 3x.
Surely the 1 over 3.
No.
What?
Log 3 is a constant. It's a number.
Yeah, it's a number.
Yeah.
So a number to the power of 0 to the power.
Numbers just become 0. It doesn't matter if it's log 3 or if it's 5, whatever, it's 0. Okay. Can I give you another one now? Scroll down? Yep. Okay, so try this one. Find the slope of the tangent if y equals x squared plus 1 over x plus 1. Oh, sorry, no, I meant to say x squared minus 1 over x minus 1. Okay.
But you just jumped across and I was up to correct.
Got an answer? What answer did you get? 2x, you say. 1, you say.
Minus x.
No, not undefined this time. There is an answer. The answer is 1. 1. Yeah.
Actually, it's x plus 1 and then derivative.
Yes. Yeah. So let me show you this one. So a common mistake people make here is that they think, oh, easy peasy. I know that the derivative of x squared is 2x, derivative of 1 is 0, derivative of x is 1, derivative of minus 1 is 0, so my answer is 2x. Okay? No. In my list of rules, were any of the functions I gave you fractions? No. No. Yeah. But we haven't done that yet, so. If you look at my list of 8 rules, was it 8 rules? Yeah. None of them were for fractions. The only rule I gave you was for this, which is actually not quite what you have here. So you have to simplify it first. Well, the way you simplify it is you change the top into this. So it becomes this. And now the derivative is 1. Yeah. You're only allowed to apply the derivative 1 by 1 if there's a plus. You can't do it in fractions. Okay? And that's so important, I'm going to say it again. Everybody look up. Look up. If you have 3 functions, for example, 1, 2, 3, and you want the derivative, you are allowed to get the derivative of the 3 of them 1 by 1. But that's the only time. Okay? If your functions were multiplied, you can't do that. If your functions were in a fraction, you can't do that. Only in the simple case can you do this. Now, we will learn in semester 2 how to deal with this, but for now we can't.
So just addition and subtraction.
Just addition and subtraction. Just simple plus minus. Okay? I'll give you another one. I'll give you an easy one now, since I've been giving you a couple of hard ones. So tell me what the derivative of sine x plus cos x is.
just cancel x minus 1 by x minus 1?
Yeah.
Cosine x minus
Okay, so what's the derivative here?
cosine x minus x.
Cos x minus sin x. Yeah? Okay, good. Right, back to a hard one now. Bum, 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 bum. Okay, can I scroll down a little bit? Right. Give me the derivative here. 0. Yeah. Yes, 0.
Sine squared.
Yes, because what does this equal? 1. So I've just asked you for the derivative of 1, which is 0. Sneaky, huh? Okay, I'll give you another one now. Yeah. Scroll down. Let's see. Right. Derivative of this one. No x's?
Yep.
Yeah, so what should we do first? Expand, very good. Yeah, we should expand first. So that's 4x squared plus 12x plus 9? Yeah, and now the derivative will be what? 8x plus 12.
I did it in a different way.
No, I want it only done this way.
There is a way you
Dude, I've been doing this for 10 years. I know much more than you, so you don't need to tell me the other way. I know there's another way, but you haven't learned that yet. So in the exam, you can't use the chain rule method. You need to pretend you're ignorant of it. Okay? In the exam, they will only want you to use the methods that you learned in the semester. Now, I know that sucks because you know other and better ways to do it. But this is life. Sorry, I keep forgetting that you're young and you don't realize that life sucks yet. It slips my mind. Right. You're figuring it out, are you? Right. Getting there. Okay, we'll do another example now. I haven't done one with exponential function yet. So give me the derivative of this function. No, yeah, that's okay. Mm-hmm. Mm-hmm.
Sure.
You got an answer.
Yeah.
What did you do first?
I did e to the power of minus 12 x, right?
Wow.
Yeah.
Well,
Minus the 1 over 2.
Okay.
No.
That's what I'm saying. Minus 1 over 2 x Which is,
You're tired.
yeah, I'm tired.
Yes, okay, yeah. No, you're right, yeah. What I'll do first is I'll just change this into ex power a half, which is equal to 1 over e a half x, which is equal to e to the power of minus a half x. Now I do have a rule, don't I? I have a rule for e nx. So the answer will be minus a half e to the minus a half x, which is actually just minus 1 over 2 root ex.
Wait, why didn't you minus 1 the power?
Look at the rule.
Okay.
I did it like
Yeah?
this. Would I lose marks because I did not show the first two steps?
No, that's okay. They sometimes expect that for these questions in the exams, the students can get the answer instantly.
Yeah.
Okay. Did you write this down? Yeah. So I'll let you try these for a few minutes. Please do all of question 1. It shouldn't take you long to do because you're just using the rule, and none of them are that hard. All of question 1.
This is page 70, right?
Yeah.
And chain rule is not allowed?
Hmm?
Chain rule is not allowed?
It is forbidden in semester 1. It's what's the word? Haram? What's
Haram.
what's the opposite of halal?
Haram.
That's it. That's what it is. It's cultural awareness, you see.